Hi, this is video 221. The objective in this video is to be able to graph parabolas using intercepts and vertex. This is stuff you've seen before from Algebra 2. But let's take a quick review. So first of all, quadratic functions, they are the form ax squared plus bx plus c. There are two scenarios. First of all, we need to know if the graph opens up or down. The one on the left here opens up. It would have an a value greater than 0. If it opens down, then the a value is less than 0. It has nothing to do with b or c. It has everything to do with the leading coefficient, they call it. The leading coefficient is always the coefficient on the largest x power. Okay, in this case, x squared is the largest power. A would be the leading coefficient. We're going to learn more about that when we look at all polynomials and not just polynomials that are to the second power. So let's take a look at a standard form equation. So the standard easier graphing form is written like you see here. A parentheses x minus h squared plus k. So this is very different than ax squared plus bx plus c. So c and k do not correspond. That's one important piece here. And of course b also does not correspond to h. They're going to be different values. So we're going to have to work with changing things to standard form because it allows us to find the information a little bit more quickly. To graph it, these are the 5 steps that you want to think about. You want to decide, is it going up or down? That's a quick check to look at A. You simply look at, is A greater than 0 or is A less than 0? Just like we saw in the last slide. The vertex. So the nice thing about this form that we see here is that the vertex is the value h, k. If I plug in h in for x, I'm going to get the largest value k possible. So the vertex is always h comma k. And remember, the vertex of a graph is simply the turnaround point. So this is the vertex of a positive a parabola, and this is a negative a. The vertex will be at the turnaround point. So it's either going to be a minimum or a maximum value. Now, the next thing we want to check for our x-intercepts and y-intercepts. So the x and y-intercepts are, of course, we want to remember that an x-intercept has such value as 0 for y, and then a y-intercept is the opposite. So we don't know what y is, but we know x is 0. So y-intercepts are quite easy to find. We're simply going to plug in 0 for x and calculate out y. But when we are looking for x-intercepts, we have to consider the opposite. So we have to consider where is y 0, and we solve this equation. When our graphs are written in standard form, you'll see it's quite easy to find your x-intercepts quickly and efficiently without much hassle. So we're going to look at that when we start graphing. And of course, your final step is to plot those points. So you'll have a vertex, you'll have a pair of x-intercepts, and you'll have a single y-intercept. And you'll also know whether the graph is going up or down, so it can help you decide if your answers are right. Let's take a look at an example here. So we're going to graph the function that you see at the top. First, we've got to decide if it's up or down, and because of the -2 here leading it, it's going to go down. Next, we want to do is find the vertex. Remember, that's your h comma k values, so this is h, this is k. So my vertex is going to be at 3 comma 8. Remember, it's not the minus in front is supposed to be there in standard form, so we want to think back to even our sines and cosines in our graphs. The 3 will cause it to be at its maximum point. Now let's see the x-intercepts. This is the one that will take a little bit more time. But we want to know when is the function 0. So we write this equation and we're going to solve. So this equation will be quite quick to solve. I'm going to -8 from both sides to get this value alone, x minus 3 squared. Then I'm going to divide both sides by -2. And it looks like I'm going to get 4 on the left equals x minus 3 squared. Now my next step is to take care of the squaring by square rooting both sides. When I square root the 4, I'm going to get 2. But remember, you want to consider both positive and negative solutions. So plus or minus 2 equals x minus 3. Because it could be positive 2 that was squared to get 4 or negative 2 that was squared to get 4. Now I'm going to add 3 to both sides to see my solutions. So it looks like my solutions are 3 plus 2 or 3 minus 2. Okay? If you're not convinced by that, let's see, they're going to be 5 and 1. You can check it by plugging it back into even this equation. 5 minus 3 is 2, squared is 4. And we can see that the same thing here. 1, put 1 in here. 1 minus 3 is negative 2, squared is 4. So my two solutions are 5 and 1. So that means my x-intercepts are at the points 5, 0, and 1, 0. So I now have 3 points to graph. I'm going to get them on there and make sure they make sense. So I'm going to check 3, 8. There's my vertex. I know my graph is going down, so this must be the maximum. Let's see, 5, 0, and 1, 0. Next thing I want to start checking for is symmetry. This vertex should be in the middle of everything, so I should be able to draw a line down and see, yes, the intercepts are balanced on either side. So that's a good sign. My y-intercept, I'm going to predict that it's going to be down here in the negatives. And so I'm going to solve for that by plugging in 0 for x into my function. I'm going to work it out, negative 2 times negative 3 squared plus 8. 3 squared is 9 times negative 2. Looks like it's going to be negative 18 plus 8, which is negative 10. So it's going to be way down at the bottom here. There's 3, 6, 9. This is 10. One nice thing about intercepts is you often can use that symmetry again. So this line of symmetry is going down. It looks like it'll take 3 to get to the line, go 3 over. And there's my other point. That can allow me to have a nice balanced graph. So definitely use the symmetry of parabolas to help you graph them. And there's your line. So remember, when it's in vertex form, it's going to be quick to graph. The hardest point is going to be getting your x-intercepts. That's going to be true no matter what form your graph is in or your function is in. So let's take a look at another example that has kind of a unique situation. So we're going to solve, we're going to decide up or down. It looks like it's going to go up because the a value is positive 1. It looks like our vertex is at negative 3, 1. Remember, standard form would be minus, so this would be minus a negative 3. Squared. X-intercepts, so remember we plug in 0 for y. We're going to get a unique result here. We're going to subtract 1 from both sides. Take a look at this. It's saying some quantity squared gives you negative 1. Well, that's impossible. That's an imaginary number. I squared gives you negative 1, but no real number. So that means that there are no x-intercepts in this case. Let's take a look at y. So if we graph the vertex, negative 3, 1, and we use what we know about the graph going up or down, we see it's going up. It's going to be going up like this somehow. So there's no way it's going to ever cross the x-axis. So this makes sense. This fits with what we already know about the graph. Now the y-intercept, let's get that, and then we'll be able to graph a complete graph. We're going to plug in 0 for x. We're going to solve. It looks like we're going to get 9 plus 1 because 3 squared is 9 plus 1 is 10. So I'm going to have this point, my vertex, and then I'm going to go up to 10. 3, 4, 5, 6, 7, 8, 9, 10. Once again, I'm going to use the symmetry. So I'm going to walk to the line where the vertex would be, and then I'm going to walk over 1, 2, 3. So I have at least 3 points to make my nice sketch. So use that symmetry to help you sketch the graph. But that's a complete graph of a parabola using simple points that we can find quickly. Let's take a look at another example. This one gets a little bit more tricky. So the graph is not in standard form. The one good thing about this form is the y-intercept is swift. So I'm going to jump straight there. The y-intercept, plugging in 0, all this becomes 0 plus 1. So it looks like my y-intercept is at 0, 1. So the good news about this form is the y-intercept is quick. I also can decide that it's down because of the fact that it's a negative x squared. But vertex and the x-intercepts are a little bit more challenging here. So this is where we need to use our skills on completing the square. So we are going to talk about completing the square quickly. If you need more help, you'll want to look at the other video provided in this section to help you. So I'm going to complete the square by taking out the negative 1 from the x squared and the x term. The plus 1 stays on the outside. So far this is equal to the original. But I need to figure out what to put here based on what is here. So I'm going to cut this in half because these would have been two single terms added together that were the same, and I get 1. And then I'm going to square the 1, and I get 1. Okay? Now, this is because now I can write this as x plus 1 squared. This is identical to what you see here. So I have it in my right term. Of course I need the negative 1. But the issue falls when we have this minus 1 right here. When we have this plus 1, that changed the value of my equation. So first I impact it by thinking, okay, well it's actually kind of a negative 1. So to adjust for that, I actually need to add 1 off to the side over here. To adjust for the fact that I put a negative 1 in my equation, I need to add it back in to think of it as 0. So now I have my form, because this will be plus 2 down here. So this is my standard form after completing the square. This is an equivalent equation to the one up above. Multiply it out, make sure you agree with it. If you don't, let me know. Bring in your questions. So the vertex for this case is going to be at negative 1, 2. So now I can see my vertex quickly, which is the whole point of completing the square. So I'm going to start graphing negative 1, 2. My y-intercept is at 1, so I have this. It looks like my x-intercepts are going to be getting close to just around 0 and negative 2. So let's see, my x-intercepts are at, when I plug this equal to 0. So 0 equals negative 1, x plus 1 squared plus 2. Solving for x, I get negative 2 equals negative 1, x plus 1 squared. Looks like I'm going to get 2 equals x plus 1 squared. Square rooting, I get plus or minus the square root of 2. Whenever I square root, I want to think of it as plus or minus, equals x plus 1. So my intercepts are going to be positive square root of 2 minus 1, because I will subtract 1 from both sides, and negative square root of 2 minus 1. I'm going to plug those into my calculator, and that's how I'm going to get my simple values. It's going to be 0.4 and 2.4, negative 2.4. And I have my graph. Okay, here's our final example. Take a moment to read it here. So when we're thinking about area, we would definitely want to define some variables, okay? We have an x and a y. We don't know if they're going to be equal or if one's going to be twice as big or whatnot. But we know that the area can be described as x times y. That's one of my equations. But the other equation I know is I know about the perimeter. I know the perimeter has to equal 100. And the perimeter is found by adding x plus y plus x plus y, or 2x plus 2y. Okay, I'm going to take a moment to solve this equation for y. This video is getting long, so I'm going to pause it here, solve it for y, and then continue watching. Okay, so here's the steps that we're going to take now. It's a system of equations, so I'm going to use substitution. So I solve for y in this case. So y is equal to 50 minus x, and I'm going to substitute it in for y here. Now this gives me a quadratic, and this is the one I want to maximize. This quadratic, if I multiply it out, is 50x minus x squared. I see the a value is negative, so this is going to be a graph with a maximum, just like I want to find that maximum. So now I'm going to complete the square. So I'm going to have negative 1 on the outside, x squared minus 50x. Okay? I'm going to divide this by 2, get 25, negative. I'm going to square it, and I get plus 625. Now, once again, I have to adjust for that out here. So it looks like it's going to be a negative 625, so I'm going to add 625 on the outside. This tells me my answer to my question. My new quadratic can be written as negative 1x minus 25 squared plus 625. That means that my maximum area is when x equals 25 and the area is 625. Because remember, y was the area and x was the value. Here are your checkpoints. Give them